All right, for example 2, it says determine dy over dx if y is equal to the square root of x over 1 plus 2x, right, using proper Leibniz notation for the quotient rule, and then simplify. Well, first thing I'm going to do is I'm going to take this high, and I'm going to turn it into x to the 1 over 2. I'm going to leave my low exactly as it is. I'm going to write it in the proper notation. So I'm going to say that dy over dx is equal to low 1 plus 2x, and the derivative of high minus high, and the derivative of low. And that is all going to be over low squared. At this point, I'm going to take the derivative of the high, derivative of the low, and I'm going to get 1 plus 2x. And this is going to give me 1 over 2, x to the negative 1/2 minus x to the 1/2 times the derivative of my low is just 2. It's all over 1 plus 2x squared. At this point, I am going to expand out this part. And because I have this negative exponent here and the fraction, I'm going to wind up factoring that out of my numerator. So I'm going to rewrite this as 1/2 x to the negative 1 over 2 times 1 plus 2x minus 2x to the 1/2 all over 1 plus 2x squared. And from that numerator, I'm going to factor out the 1/2 and the x to the negative 1/2 from both terms. When I pull it out of the first, it's just going to be 1 plus 2x. And when I divide negative 2x to the 1/2 by 1/2 x to the negative 1/2, then that's just going to leave me with negative 4x. And that's all over 1 plus 2x squared. I'm going to move the denominator of the 1/2 to the bottom. I'm going to move that negative exponent for x down to the bottom. And because it's to the 1/2, I'm going to say it is going to be 2 and the square root of x multiplied by 1 plus 2x squared. And in the numerator, I'm going to combine those. And I'm just going to have 1 minus 2x. And I am done. All right, let's try one last example for this. So if I'm going to differentiate y is equal to x squared plus 3x plus 2 over x squared plus x minus 2, then I have my high, I have my low, and I'm going to say that dy over dx is equal to the high x squared plus 3x, the low x squared plus x minus 2 times d over dx of the high, x squared plus 3x plus 2 minus the high, x squared plus 3x plus 2, and d over dx of the low, x squared plus x minus 2. And that is all over x squared plus x minus 2 squared. This is going to give me x squared plus x minus 2 times 2x plus 3 minus x squared plus 3x plus 2 times 2x plus 1. And that's all over x squared plus x minus 2 squared. Now I'm going to check if I can factor. Well, I can absolutely factor this, I can factor this, and I can factor this. So once I factor them, I'm going to wind up with x plus 2 times x minus 1 times 2x plus 3 minus x plus 2 and x plus 1 and 2x plus 1 all over x plus 2, x minus 1 squared. Well, I have a common factor here, here, and here. Now I just got to be careful because the bottom is squared. I actually have two x plus 2's, which means that when I factor this, I really have x minus 1 squared and x plus 2 squared, which means that when I remove the common factor, I'm just taking away one of them. That's going to leave me with x minus 1, 2x plus 3, minus x plus 1, 2x plus 1, all over x plus 2 and x minus 1 squared. I'm going to expand out because I can't factor any further. So I'm going to get 2x squared plus x minus 3 minus 2x squared plus 3x plus 1 all over x plus 2, not 2x, and x minus 1 squared. Or if I have 2x squared plus x minus 3 minus 2x squared minus 3x minus 1 all over x plus 2 and x minus 1 squared, then the 2x squared and the negative 2x squared are going to cancel each other out. And I'm going to wind up with negative 2x minus 4 over x plus 2 and x minus 1 squared. And lo and behold, I can factor again. I can pull out a negative 2. and I get x plus 2 all over x plus 2 and x minus 1 squared. And I can cancel out an x plus 2. And I finally wind up with my final answer, dy over dx is actually equal to negative 2 over x minus 1 squared. All right. Make sure that you go and complete the 2.6 investigation before our 2.6 class.